Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today we will discuss about these three topics. First is the electric field, the second one is the electric field intensity, and the third topic we will discuss in this video is electric field lines. And similarly we will focus on the electric field lines between two long parallel plates, just like in capacitor and in batteries. And similarly we will explore what will happen if we bring a positive charge near to emitter. So in this video we will focus actually the electric field lines between a charge body and emitter. So let's start the video by simulation. So here is the some advanced simulation. So at the center there is a charge, and around it radially outward in three dimension the lines are originating. So these lines actually originate from this positive charge in three dimension, not in two dimension. And the direction of this electric field line is outward. So these lines are extended up to some region, not in this all board or in this all screen, but it is confined up to some region, up to here. So it is confined up to this border. Okay, these lines are up to up to this region. Okay, these lines do not cross this region, the region around the charge up to which these lines are have extended. This region is called electric. This region is called electric field. This region is actually called electric field. Electric field is actually the region around the electric field is actually the region around a charge body up to which the effect of that charge is present. So the effect of this charge is present up to this region, and this region is called electric field. Now this region here you see that this region is actually represented by lines which is originating from this positive charge. Okay, in physics that line is called electric field line. Electric field line is nothing but this is actually the lines which is originating in this case from the positive charge and radially outward from it up to the region to which the effect of this charge is present. So in this case these lines you see from this positive charge is called the electric field line. So this line is called electric field line. Electric field line. So there are large number of lines originating from this positive charge. So these lines are called electric field lines. Okay, these lines are called electric field lines. And when another charge is present inside the field of this positive charge, there will be some sort of force exert on that positive charge. Let's and another charge which is also a positive charge and enter into the region around this positive charge. So there will be some sort of repulsive force, okay, on this charge. So we can say that we can visualize that in the another simulation. So here this is the other simulation. Now we will explore the concept of electric field intensity. So for that let's take a negative charge from this box and put that into our lab for experiment. So here will be some electric field lines creating around it. and inside that field and another positive charge present. So let's this is actually a positive discharge. This is actually a discharge and represented as Q naught. This is actually a source charge and label is Q. So here will be some force of attraction between this discharge and this source charge, because this discharge is present in the field around this negative charge. Okay, so let's start the simulation. By clicking on this start button. This positive charge is moving toward this negative charge, and the speed of this positive charge is increasing as we come near to this negative charge. So now we will focus on why the speed of the positive charge is increasing when we come near to this negative charge, and let's see that again. Here focus on the speed of this positive discharge. This is actually increasing as we going near to the source charge. In the other word, we can say that the force and this positive discharge is increasing when we come near to this negative charge. Okay, the force on this discharge in this point is different, and the force on this discharge in this point and the force on that discharge in this point will be different. In this point the force on that discharge will be more, because the distance between these two charges is smaller, and the force on discharge in this position will be higher as compared to this position. Okay, now the force on the discharge is called electric field intensity. Electric field intensity is nothing but this is actually the force per unit discharge. The force per unit discharge is called electric field intensity. In other words, we can say that the electric field intensity is increasing as we come near to this source charge. Electric field intensity is actually the force per unit discharge, and that the force per unit discharge is increasing as we going near to this negative charge. So we can also say that the electric field intensity is increasing when we approaching toward this negative charge. So let's going towards the mathematics for this. Electric field intensity is actually the force per unit discharge. In this case, the force between this force is actually the force between the discharge and this source charge, and the force between the two charges is given by the Coulomb law, which is equal to let's write this again here. This is E, and we write equal sign in their own place, and now replace this if by now taking the value of this if. This is actually the Coulomb force, which is K Q1 Q2. Here in this case Q1 is Q naught, a source charge, and Q2 is Q naught is a discharge and Q is the source charge, divided by R square. This is a expression is come from the Coulomb law, and this has written for this if. Now this whole divided by Q naught. Here this Q naught and this Q naught cancel. Now the E, the electric field intensity become K, E is equal to K Q, okay, divided by R square. E is equal to K Q by R square, and this is the formula for the electric field intensity. Electric field intensity. Now this is the scalar form. Scalar form. But we can also write this in a vector form, because electric field intensity is a vector quantity. So for that the vector form is electric. This is the electric field intensity in vector form. E is equal to K Q KQ by R square. Okay, KQ by R square, and here we will write our unit vector. Okay, this all about the electric field lines and electric field intensity. Until here we discuss all concept related to a single charge. As this is a positive single charge, and there is electric field lines originating from this positive charge, and this is the a single vector field. And this vector field, this is actually a vector field, a line which is called electric field line. So here this vector have direction and magnitude. Here it has direction and magnitude, so I am going to label that. Okay, this is actually a positive charge. It is surrounded by large number of lines, and we as we discussed till here, these lines are called electric field lines, and this is actually a representation for the space around this positive charge. Up to that space, the effect of this positive charge is exist. So that space is represented by these lines you see here. These lines is nothing but these are actually a vector. So these lines are actually vectors. Here this vector, so here the head of this vector represent the direction of a field, electric field line. These are actually electric field lines. So this represents the direction of electric field line, the head of this vector, and the tail of this vector represent the magnitude of electric field line. So this all about the electric field line for a single positive charge. Okay, now I am going to rub this, and now take the second charge, which is a negative charge. So bring this negative charge to here. Now you can see here that the number of electric lines, these vectors, actually I am talking about these vectors. These vectors are actually pointing towards this negative charge. Okay, and in this case this is positive charge. these vectors are moving away from the positive charge. This is the intrinsic nature, and this is the a representation for the electric field lines for the positive charge and the negative charge. Okay, in this case these are the electric field line representation. In this case the lines are originating from the positive charge and moving towards the negative charge and then terminate into the negative charge. Okay, in this way these two charges attract each other. Okay, let's restart this simulation by clicking on this button, and now let's take two same charges, like charges. This is we have a positive charge and I'm going to release it here. Now take the second positive charge and release it here. Okay, release it here. Now this is the electric field lines around it, and in this case the electric field lines are moving away from this positive charge. Okay, and similarly the electric field lines are moving away from this positive charge as well. So in this case here they both cancel each other. Okay, and therefore they change the direction, and here the electric field strength will be decreased. So I'm not going in detail here, but I am going to mention the concept of electric field lines for a single charge. And now we are going to discuss what is the electric field lines between two plates. What will be the concept for the electric field lines between the two plates? So here I am going to increase the length of these plates. This is nothing but this is actually a capacitor. Capacitor have usually these plates. This is actually a one plate and this is the other plate. This plate is actually connected to the positive terminal of the battery, and similarly this plate is connected through the wire to the battery. Here it is the negative side. Now the battery is off and I'm going to on this battery. Before on this battery there is no charge on this plate. Now I am going to on the battery. So if I on the battery, as this plate through this wire connected to the positive terminal of the battery, the positive charge will move to this positive plate, and in the same way the negative charge move to this negative plate. Now we know that the electric field line will originate from the positive charge and will terminate to the negative charge. Let's consider this one positive charge and this one negative charge. So the electric field line will originate from this positive charge and will terminate in this negative charge. Similarly, the electric field line will originate from this second positive charge and will terminate on this negative charge. In the same way, the charge will originate from this positive charge and will terminate on this negative charge. Again from this positive charge to this negative charge, and in this way the electric field lines will arrange between these two plates. So I'm going to rub this and now in this simulation we have a button here for the electric field line. So this is electric field lines. If I click this, this is how it look like. these plates has positive charge and these plates have negative charge, so there will be electric field lines originating from this positive charge and will terminate into the negative charge. So this is the direction for that electric field line between these two plates. So this is the concept for electric field lines between two plates. This phenomena is actually occur in the what we can say in the capacitor. Let's start the last topic and then we will close this session. So the last topic which is remaining is actually the electric field lines between our charge body and its interaction with the metal. So the interaction of field lines with metal. Okay, now we will discuss that. So let's consider a charge. Okay, here we have a positive charge, large number of positive charge. This is 1 2 3 4, this is 5 6 and 7. Okay, these are positive charges. So here will be the electric field lines originating from these, so that will going toward outward. Okay, because these are positive charge and this electric field lines are away from this. Okay, these are actually away from this. Okay, these are actually electric field lines moving away from this positive charge. These lines are moving away from this positive charge. Actually these are, the direction is in this way. Now think about this scenario. These are positive charges, and let's consider a metal, and this is actually a metal. Okay, this is a metal. I am trying to draw that. This is a metal. Okay, and let's extend and we know that there are positive this metal is actually, this is actually a metal. So this metal is made up of large number of atoms, and inside atom there are electron and proton, mean the negative charges and the positive charge. Here in metal there are sea of negative charges, okay, and positive charges and negative charge. Okay, there are large number of positive and negative charge. Okay, these are large number of positive and negative charges. So what will happen if I bring this metal near to into this field lines, into the field around these positive charges? Let's take this. Okay, this is actually the metal. Okay, and bring that into the field of this charge. Now into the field around this charge. Okay, in this case what will happen? In this case this electric field lines will interact, these electric field line will interact with the metal. Okay, these electric field lines will interact with the metal. So as these electric field lines are originating from the positive charges, and when they interact with the metal, it will attract the negative charges of the metal towards itself, due to which these all negative charges present in the metal will come to the left side towards this positive charge, and these positive charges will move away from this positive charge, and due to which it will arrange on the right side of the metal. So in this scenario, actually I'm going to draw okay, I'm going to draw the metal, that same metal, and let's visualize that. Okay, here I'm going to explain the concept. So when the metal come inside the electric the positive the electric field lines of these positive charges, due to which the negative charges present in the metal will be attracted toward this positive charge, due to which these negative electrons will arrange on this side of the metal. Okay, when the electrons moving towards this negative electrons, and these positive charges will repel these positive charges present in the metal, due to which the positive charges will arrange on this side. Okay, so this all about the electric field lines interaction with the metal. So if the external charges are positive charges, the electric field lines moving away from it, and when metal come into that field, the electrons present in the metal will attract it towards these positive charges, and the positive charges present in the metal will be repel and will arrange on the right side of the metal as. Okay, and these are about the interaction of field lines with metal. First we consider this, then these positive and negative charges are arranged randomly because there is no electric field lines interaction with this metal. But when we bring this metal inside the electric field line of the charges is here, okay, the metals inside the metal, the electrons and proton will arrange, and the map of the arrangement of these charges inside the metal is represented by this. And that are about today lecture. Okay, thanks for watching.